Hi guys, so today we're going to be talking about multiplying matrices. It's slightly more complicated than just adding and subtracting. And in terms of dimensions, it's a little bit different, right? So when we were adding and subtracting matrices, the dimensions had to be the same. However, now when we're multiplying matrices, what really happens is the columns of one has to be the same as the rows of another, right? So for example, with example one, it asks us, determine whether each matrix product is defined, meaning is it possible to multiply these matrices together? Okay. If so, we want to state the dimensions of the product. Okay. So here we have matrix A. It is 2 by 5, so it has 2 rows and 5 columns. Our B matrix is a 5 by 4, meaning it has 5 rows and 4 columns, okay? And what you have to be careful for or check for is when you're multiplying matrices, you need to make sure that these two numbers are the same, where the columns of your first one is the same as the rows of your second one, okay? If it is, then what's going to happen is this is now going to be, the other two numbers are now going to be the dimensions of your new matrix. Okay, so now AB will be a 2 by 4 matrix. Okay. So here, the next one is B. Okay, so A here is a 1 by 3 matrix, so 1 row, 3 columns. And the B matrix is a 4 by 3, meaning 4 rows and 3 columns. Okay, and then here, when we look, okay, it is not the same, right? So what your book describes it as is the inner dimensions are not equal. And so what that means is that the product, the matrix product, is not defined, which means we can't multiply them. Matrix product is not defined. Okay? So you're going to check your progress 1A and 1B, and then come check your answer once you're done. Okay, so for CYP 1A, you should have gotten a 4 by 2 matrix. And then for 1B, because the inner dimensions are not equal, the matrix product is not defined. Okay, so now what we're going to do is we're going to work on multiplying our matrices. Okay, so it can get a little bit complicated sometimes. So what we're going to do is I'm going to try color coding some stuff for us, and then hopefully it will make it a little bit easier. Right? Okay. So here we want to find RS. We want to multiply matrix R with matrix S. Okay? So what's going to happen first is I'm going to highlight this pink. I'm going to highlight this orange. I'm going to highlight this yellow. And then I'm going to highlight this blue. In the book actually does a good job on kind of explaining it step by step. So hopefully that kind of helps a little as well, in addition to this video. Okay. So what we're going to do, so here we're finding matrix RS. Okay. So first, what we're going to do is we're going to take the row of the first one and the column of the column of the second one and multiply them, right? So what that's going to be is it's going to be 2 times 3. And then since this is a negative, we'll do a minus 1 times 5. Okay? And so what we did is we took the row of the first matrix and the column of the second matrix, and then we multiplied them and added them. Right? So then the next one, we're going to do the same thing. We're going to take the row of the first one and the column of this, the second column of the second one. So this will be 2 times negative 9 minus 1 times 7. Oops. So again, first row now, and then second column, the other one. Okay. Then, for our third element, now we're going to move on. Since this is the bottom row, we're going to move to the bottom row here. And since this is first column here. So bottom row of the first matrix, first column of the second matrix. So this will be 3 times 3. And then since this is a positive, we'll do a plus 4 times 5. Okay. So here, this one, bottom row, first column. Okay. And the next one will again be bottom row, but this time it'll be second column. So 3, negative 9. And then again, since it's a positive 4, it'll be plus 4, 7. Okay. So hopefully with the color coding, you're starting to see some pattern with this. Okay. It can get confusing at times, so I would just slow down and make sure I'm doing the right rows, right columns, right elements. Okay. So here, 2 times 3 is 6, negative 1 times 5 is negative 5. Okay. 2 times negative 9 is negative 18. Negative 1 times 7 is negative 7. 3 times 3 is 9. 4 times 5 is 20. 3 times negative 9 is negative 27. 4 times 7 is 28. Then, simplifying, 6 minus 5 is 1. Negative 18 minus 7 is negative 25. 9 plus 20 is 29. And negative 27 plus 28 is 1. And so this is my resulting matrix multiplication. Okay, so you're going to try CYP2 on your own. And then once you're done, come check your answer. Okay, this is what you should have gotten. 64, negative 50, negative 18, 13. Okay, if you got it, you can move on to the next example. If not, here's your explanation. Okay, so here, UV, I'm going to start with first row and first column. So 5 times 2, 9 times 6. Okay, the next one is going to be first row again, but this time it's second column. 5 times negative 1. 9 times negative 5. Okay. Then for the position here, it's now going to be second row, first column, negative 3 times 2, and the negative 2 times 6. Okay. And then the last one here, second row, last column, negative 3 times negative 1, negative 2 times negative 5. Okay. 5 times 2 is 10, 9 times 6 is 54. 5 times negative 1 is negative 5, 9 times negative 5 is negative 45. Negative 3 times 2 is negative 6. Negative 2 times 6 is negative 12. Negative 3 times negative 1 is 3. Negative 2 times negative 5 is 10. 10 plus 54 is 64. Negative 5 minus 45 is negative 50. Negative 6 minus 12 is negative 18. And 3 plus 10 is 13. Okay. So the next one here is example 3. Okay. So at a particular swim meet, 7 points were awarded for each first place finish, 4 points for each second, and 2 points for each third. We want to know which school won the meet. Okay. So what we can do first is that the final scores can be found by multiplying the swim results for each school by the points awarded for each first, second, and third place. Okay. So what we're going to do first is we're going to write the results of the races and the points awarded in matrix form. And then we're going to set up the matrices so that the number of rows in the points matrix equals the number of columns in the results matrix. Okay. So we're going to start with our results. Okay. So for the first school, we have 4, 8, 10, 3, 4, 8, 10, 3, 7, 9, 5, 3, 7, 9, 5, 3, 3, 1, 3, 6, 3, 1, 3, 6. Okay. Then we're going to do our points. And so we want 7 points for first, 4 points for second, and 2 points for third. Okay. Then what we're going to do is we're going to multiply. Okay. So I'm going to start by highlighting. I don't think I have enough colors, but we'll try our best. Okay. I don't think I have enough colors. That's okay, because we're multiplying all of them by this. Okay. So then, let's multiply R times P. Okay. So we're going to start with first row and then the column. So it's going to be 4 times 7, 7 times 4, and then 3 times 2. Okay. So this is the ones from the first row, and then these are our points, right? Because they got 4 first place, so 4 times 7 is their points. 7 second places, so 7 times 4 is their points, and then 3 third places, so 3 times 2 is their points. Okay. Now let's keep multiplying. So the next school would be 8 times 7, 9 times 4, and 1 times 2. So this is the second row in that column. Okay. Next, we'll do third row in this column. So then that's 10 times 7, 5 times 4, and 3 times 2. Okay. So this is the third row's winnings. And then the last row will be the last school. So 3 times 7, 3 times 4, and 6 times 2. Okay. So then let us simplify it. Okay. 4 times 7 is 28, 7 times 4 is 28, 3 times 2 is 6. 8 times 7 is 56, 9 times 4 is 36, and 1 times 2 is 2. 10 times 7 is 70, 5 times 4 is 20, 3 times 2 is 6. 3 times 7 is 20, 3 times 4 is 12, 6 times 2 is also 12. Okay. And then now we're going to add them. Turn this down. Okay, so 28, 28, 6 is 62. 56, 36, 2 is 94. 70, 20, and 6 is 96. 21, 12, and 12 is 45. Okay. So here, this corresponds to each of the schools, Central, Franklin, Hayes, and Lincoln. And so here, this third one is the most, and so Hayes won the swim meet. So Hayes won the swim meet with 96 points. Okay, you're now going to work on check your progress 3, and then once you're done, come check your answer. Okay, for check your progress 3, you should have gotten 431,199. If you did, you can move on to the next example. If not, here's your explanation. So basically, I took this table from page 174 and converted it into a matrix. Then I made a matrix using the prices, 250, 225, 149, 75. Then I multiplied it. So each one with row and column. So 325, 250, 215, 225, 147, 149, and 276, 75. Did the same thing with the next row, 294, 250, 221, 225, 79, 149, 152, 75. Okay. Same thing with the third row, 175, 250, 191, 225, 100, 149, and 146, 75. Okay, multiplied each of them, and then added for each of them, and then got totals, right? So total for store 1, total for store 2, total for store 3. Then I added the total for all 3 stores and got this amount here. Okay, so next what we're going to talk about is we're going to talk about whether or not the commutative property and the distributive property work for matrices. Okay, so hold on. Okay, so first thing, right, commutative property. The commutative property of multiplication told us that 2 times 3 was the same as 3 times 2. Okay, and so what we're going to see here is, does this same property, commutative property, work for matrices? And so we're going to do that by doing PQ times QP, or PQ, and does it equal to QP? Okay, so let's start with PQ here. So we're going to multiply rows and column, row and column, row and column. Okay, so keep in mind that P is a 3 by 2 matrix and this is a 2 by 3 matrix. Okay, so it does work for PQ because the inner dimensions are the same, they're both 2. Okay. As well, if we did Q and P, then the inner dimensions would be that 3. Okay, so let's get started. Okay. So with PQ, first row, first column. So this would be 8 times 9 minus 7 times 6. Then the next one again will be first row, second column now. So this is 8 times negative 3. Negative 7 times negative 1. Okay. So again, with multiplying, I would go nice and slow so that way you don't make a mistake. Right, so 8 times negative 7 now, and then, or 8 and negative 7 first row, and now third column. 8 and 2, negative 7, and negative 5. Okay, hopefully I don't run out of space. Okay, next I'm going to do the second row for this. Okay, so second row, first column, second row, second column, second row, third column. So negative 2, 9, and 4, and 6. Okay. And the next, negative 2, negative 3, and 4, negative 1. Okay, then again, second row, last column now, negative 2, 2, and 4, negative 5. Okay, then moving on to my last row in the different columns. So 0, 9, and 3, 6. 0, negative 3, and 3, negative 1. 0, 2, and 3, negative 5. Okay. So now I'm going to simplify. Okay. 8 times 9 is 72, negative 7 and 6 is negative 42. 8 and negative 3 is negative 24. This is 7. 8 times 2 is 16. Negative 7 and negative 5 is 35. Negative 2 and 9 is negative 18. 4 and 6 is 24. Negative 2 and negative 3 is 6. 4 and negative 1 is negative 4. Negative 2 and 2 is negative 4. 4 and negative 5 is negative 20. Okay. 0 times 9 is 0. 3 and 6 is 18. 0 and negative 3 is 0. 3 and negative 1 is negative 3. 0 and 2 is 0. 3 and negative 5 is negative 15. Okay. Last part on simplifying. Might have to change pens again. 72 minus 42 is 30. Negative 24 plus 7 is negative 17. 16 plus 35, 51. Okay. Negative 18 plus 24 is 6. 6 minus 4 is 2. Negative 4 minus 20 is negative 24. 0 plus 18 is 18. 0 minus 3 is negative 3. And 0 minus 15 is negative 15. And so I got 30, negative 17, 51, 6, 2, negative 24, 18, negative 3, and negative 15. Okay, so now that was PQ. We're going to do QP now. Okay, so this time we're actually going to start with this row and we're going to use these columns. So keep that in mind. We're kind of switching it over because now it's Q multiplying P. Okay, so I'm actually going to start with this row. Okay, and this column. So it's going to be 9 times 8, negative 3 times negative 2, and 2 times 0. Okay, so note, I use this row and this column. Okay, so next one I'm going to use this row and now the second column. So 9, negative 7, negative 3, 4, and 2, 3. So again, it can get difficult with multiplication, so you might even write Q and then P, so that way you know the order, because right now it kind of looks like we're going backwards. Okay? Then it's going to be this row and this column, this element. So it'll be 6 times 8, negative 1 times negative 2, and negative 5 times 0. Okay. Then again, second row, now it's second column. So 6, negative 7, negative 1, 4, and negative 5, 3. Okay, so then let's simplify. Okay, 9 times 8, 72, 6, and 0. This is negative 63, negative 12, and 6. 6, 8, 48, negative 1, 9, 2 is positive 2, and 0. This is negative 42 minus 4 minus 15. Okay, then let's simplify. 72 plus 6 is 78. Negative 63 minus 12 plus 6 is negative 69. Okay. 48 plus 2 minus 0 is 50. And then negative 42 minus 4 minus 15 is negative 61. Okay. As you can see, PQ's result and QP's result is not the same. And so what that means is the commutative property does not apply to matrices. Okay? So here you're going to do number 4 on your own. And then once you're done, you're going to come check your answer. Okay, so for AB, you should have gotten negative 8, 19, negative 7, 20. For BA, you should have gotten 18, negative 9, 9, negative 6. And what that means is since they're not the same, AB is not equal to BA in this situation. Okay, so the next and last property we're going to explore for matrices is the distributive property. Okay, and so the first one we're going to do is A times B plus C. Or A times the quantity of B plus C. And then we're going to see, is it the same as A times B plus A times C? Okay, so we're going to start first with B plus C. Okay. So here we're just adding, right? So it's the element adding to the corresponding element in the other matrix, right? So if we're going to do the B plus C part first, it's negative 2 plus 1. Okay. 5 plus 1, 6 plus negative 5, and 7 plus 3. Okay. Let's simplify it. Negative 2 plus 1 is negative 1, 5 plus 1 is 6, 6 plus negative 5 is 1, and 7 plus 3 is 10. Okay. Then, what we're going to do now is we're going to multiply A with it. Okay. So now we're going to do the next part, which is A times B plus C. Right? And so this is what B plus C is. Okay. So since A is the one on the left, we're going to start with rows of this A and then the column for this. Okay. So starting here, it'll be 3 times negative 1. And then 2 times 1. Okay. Next one will be this row and this column. So 3 times 6 and 2 times 10. Okay, then we're going to move to second row now. So second row and first column, it will be -1 times -1 and 4 times 1. Okay, then second row and second column, so -1 times 6 and 4 times 10. Okay, and then we're going to simplify. Okay, 3 times -1 is -3, 2 times 1 is 2, 3 times 6 is 18, 2 times 10 is 20, -1 times -1 is 1, 4 times 1 is 4, -1 times 6 is -6, 4 times 10 is 40. Okay, simplify, -3 plus 2 is -1, 1 plus 4 is 5, 18 plus 20 is 38, and -6 plus 4 is 34. And so this results in -1, 38, 5, and 34. Okay, so that's what A times the quantity of B plus C is. Okay, so now let's see if AB plus AC is the same. Okay, so I'm going to put a little line of partition, just so, although there's so many lines of matrices and everything. Oh, well, pen is dying. Okay, there you go. Okay, so that way we can keep it separate. We're seeing, is it going to be the same thing? Because if it is, then the distributive property at least works with this example. Okay, so first we're going to do AB. So we're going to multiply this matrix by this matrix. So since A is the one that's on the left, we're going to use A's rows and B's columns. Okay, so here we have 3 and -2. And 2 and 6. Okay. Then it'll be 3 and 5 and 2 times 7. Okay. Then we're going to move on to second row and columns. So that will be -1 and -2, 4 times 6. Okay. -1 times 5 and 4 times 7. Okay, then let's simplify. 3 times -2 is -6, 2 times 6 is 12, 3 times 5 is 15, 2 times 7 is 14, -1, -2 is 2, 4 times 6 is 24, -1, 5 is -5, 4 times 7 is 28. Okay, and simplify. -6 plus 12 is 6, 15 plus 14 is 29. 2 plus 24 is 26, and -5 plus 28 is 23. Okay, so we're still not done. Okay, now we're going to work on AC, and then we're going to add this and whatever AC is. Okay, so AC is this and this. Okay, so again, since A is on the left, we're going to use A's rows and C's columns. Okay. So here we start with A's rows, so 3, 1, and 2, 1. Okay, sorry, 2, -5. That's why we got to be careful, right? Rows, columns. Okay, then again, rows, and then other columns. So that will be 3 times 1, and 2 times 3. Okay. Then we're going to move on to second row and columns. So that's -1 and 1 and 4 and -5. And the other one's second row, second column, -1, 1 and 4, 3. Okay, let's simplify. 3 times 1 is 3, 2 times -5 is -10, 3 times 1 is 3, 2 times 3 is 6. -1 times 1 is -1, 4 times -5 is -20. -1 times 1 is -1, 4 times 3 is 12. Okay, simplify that. 3 minus 10 is -7, 3 plus 6 is 9, -1 minus 20 is -21, and -1 plus 12 is 11. Okay, now we're going to add them too. So we're going to do the purple plus the pink. Let's pick another color. Let's do green now. So then AB plus AC. We have AB here, we have AC here. When we're adding, we just need to add the elements, corresponding elements together. So that'll be 6 plus negative 7, 29 plus 9, 26 plus negative 21, and 23 plus 11. Okay. 6 plus negative 7 is negative 1, 29 plus 9 is 38, 26 plus negative 21 is 5, and 23 plus 11 is 34. They do match, so in this case, the distributive property does work. Okay? So I'm now going to have you try to check your progress 5, and then once you're done, come check your answer. Okay, so for both, you should have gotten 15, 38, 1, 45. And so what that means for us is that S plus T, the quantity of S plus T times R does equal SR plus TR. So with this example, the distributive property also works. Before I get to explaining that, you should look at page 181 on properties of matrix multiplication. What it tells us is that when we multiply matrices, the associative property of matrix multiplication, the associative property of scalar multiplication, and both the distributive property, either from the left or the right, also works. And so it's really the commutative property that does not work for matrix multiplication. Okay, so if you got the last check your progress correct, you can get started on homework. If not, here is your explanation. Okay, so the first part I did the quantity of S plus T and then multiplied by R. So quantity of S plus T, matrix addition, you're just adding corresponding elements together. So 4 plus negative 3, 6 plus 7, negative 2 plus negative 4, and 5 plus 8. That will give you this, 1, 13, negative 6, and 13. Then, with that, I'm going to multiply it with R. So note that because the S plus T is on the left, we're going to be using this one's rows and R's columns. So it's going to be 1 times 2 plus 13 times 1. Okay. And then same thing, this row and this column now, 1 times negative 1 and 13 times 3. Okay. Then we're going to move on to the rows for negative 6 and 13, and then this column. So negative 6 times 2 and 13 times 1. And then moving to the second column, negative 6 times negative 1 and 13 times 3. Okay. And then when you simplify it, you'll get 15, 38, 1, 45 for the quantity of S plus T times R. Okay. Then the other side is SRTR. And then you're going to add them. So here, since S is on the left, that means you're going to be using S's rows and R's columns. So keep in mind it will then be 4 times 2 and 6 and 1. Okay? And then it'll be 4 and negative 1 and 6 and 3. Okay? Then again, you're using the S's rows. So negative 2, 5 is next. Negative 2 and 2, 5 and 1. Negative 2 and negative 1, and 5 and 3 will give you this. Then you simplify it and you'll get this, 14, 14, 1, 17. Okay. Then it's the TR part. Since T is the one on the left, you're going to be using T's rows. Okay. So it'll be negative 3 and 2 and 7, 1. And then negative 3 and negative 1 and 7, 3. Okay. Then again, you're still using T's rows, so it'll be T's second row. Negative 4 times 2, 8 times 1, negative 4 times negative 1, and 8 times 3. Okay. When you simplify it, you'll get 1, 24, 0, and 28 here. Okay. Then, now I'm going to add the two SR and TR, or this purple matrix and this blue. So it's just corresponding parts. So 14 plus 1 gives me 15. 14 plus 24 gives me the 38. 1 plus 0 is 1, and 17 plus 28 is 45. And since they are the same here, that is why the distributive property works. Okay, so that's it for today. Have a great rest of the day. Bye, guys.